making this video because I couldn't find very much information with regards to how to make this sensor work, which is the Vl6180 or the Vl6180 X, which is a time of flight range sensor. I couldn't find very much information on how to make this work with Matlab's Simulink, but I did find when I was going through looking for how to make it work with Matlab Simulink, I did find that a lot of the people had the same questions or had the same problem. How do you make it work? So what I did was I got it to work, and now I'm going to just post a video on how I did it. So the first thing, just like I'm assuming you know basic electronics, so you plug the sensor in to some DuPont cables. And so for this video I'm using the ground, the VCC power, the SDA and SCL. So for those who don't know, this is an I2C sensor, and I'm using an Arduino Mega board that I'm plugging into the computer. And so I'm plugging in on the Arduino, I'm plugging it into the ground and the 5 volt and also the SDA and SCL wires over here. And I'm just going to plug that into my computer like normal. Actually, let me take this. I got this banded up, so let me take this off first so I can show it to you a little easier. I'm a little OCD about my wiring. Take that apart. Alright. And so for this, all you need is just basically the Mega, the wires, and the sensor. Alright, and so I've already written this, so I'm not going to show you how to write it. I'm just going to show you what I did, and you can, for instance, if you're wanting to code, then you can just watch the video in slow motion and take the code yourself. So, so the first thing is, in general, if you don't know much about Simulink, so after you create a Simulink model or have a blank page, for instance here, is this running? Okay, so let me make sure that's running here. Okay. So in this, if you haven't used Simulink, you should download for the Arduino, which is the Arduino support package, which is listed online down here. So if you don't see this, you're going to have to do this first, but there is a lot of videos on this, so this really should not be a problem. And so whenever you go into this, you'll find different blocks and things like that with regards to Arduino. However, the I2C blocks, like here and here, are actually a little bit difficult to use because it really just sends like one byte of information, maybe the identifier, etc. But it doesn't really send like a good stream of multiple types of bits. It's not really set up for that. So for this type of sensor, you really have to use a special function. You have to write it yourself, and it is I haven't done this in a while, so I'm trying to track back through here. It's an S-function. And so this one right here is an example. It's the S-function builder. So I used this one right here, the S-function builder. And so I'm not going to open up a new one. What I'm going to do is I'm just going to open up the one I've already written. So you can see this is an S-function builder, and it has no inputs and one output because this sensor has no inputs to it. So I'm opening up just this S-function eventually. Okay, and so this is the S-function that I was showing you already, which is already built, so you can see the name up here. And these tabs here, if you don't know anything about S-functions, are kind of how you set up the inputs, the outputs, and the code that is within the S-function. So for this, I set my sample time at basically 1,000, or I mean at 100. Which really is faster than the sensor can can sample. It really has a sampling rate of around 50, but this worked, and so I'm just letting it run the way it is. Why change something that works? And number of discrete states set at 1. So then in this right here under data and properties, there are no inputs, that's why there's nothing here, but in outputs you'll see I've put the distance. Now the distance will output in a 0 to 255 number, and so let's see here, I'll show you. And you have to set it as a type double. And then, now this is where the code actually starts to come through. So under libraries, these are all of the libraries that you'll have to define. Now, let's see, I can't stretch this out again. Okay. So I'm going to give you the code. I'm going to scroll through it slowly, but also I'm going to explain a little bit of it. So this right here is really just saying that all of this stuff below it, it's kind of like encasing it. I'm not going to go into a lot of detail, but this statement is not a include statement. It's really encasing. Stop it. It's really encasing all of this code, and you can see the indif of it is at the very bottom. So these right here are your main includes to make this work, and actually I don't think the wires are actually used in mine. I actually think only the TWIs, which is 2-wire, because I went to a lower level to get the functions that I was using, and I went below wire, I believe. So I don't even think these are necessary, but you know, I would just, if you're going to copy my code, I would just put them in there. So then I'll go through slowly. Now all of these define statements here come from SparkFun's reference to, I believe it's GitHub, where they have code. And so I just went into SparkFun's reference files for this sensor, and just basically I wrote them down exactly how it was as all of the defines for it. So I'm just going to scroll through them somewhat slowly. So, and it took a little bit of time to write all this, so make sure you have it right. So there's all the libraries. So this is all the libraries to the sections. Now we go into the, let's see, we'll do the discrete one first. So what I did here is I skipped over these two tabs for a second and went over to the discrete update. So we're going to scroll to the top here. Now the discrete update is the thing that happens one time essentially for your program. It is the kind of like these set. Let's see. In Arduino terms, it's the void setup. So this is basically your void setup, and you can see I have basically it'll run at once. If it's not 1, it'll do this, and then at the bottom it'll set it to 1, so it will no longer do it. So we'll only do it one time. So then I'll scroll through the code without. I'm going to give you just a brief description of what happens. I'm not going to run through each line of code because there's a lot of code. So basically what happens is I did each one in a section where I'm doing setup, and then like set up a register. This has numerous registers on it that you have to set prior to it working correctly. So each register is just basically, or each little block is just setting up another register. So you can see each block setting up another register, setting up another register. So that's all this is, all the way to the bottom. So I'll scroll through this somewhat slow. Let's see. Okay. And as you can see, there are, like I said, numerous registers to set up at the beginning. And I took a lot of the delays out. I tried to get it to sample as fast as I could. So some of the parameters have been changed from the SparkFun GitHub references to try to get it to go as fast as possible. And like I said, I really only got it to sample at maybe 50, maybe a little over 50, somewhere in there, under 100. And so now we're into the Outputs tab. And so the Outputs tab. Now this tab actually, when I was first running this, was really I almost didn't have to set anything up just to get an output. It was just incorrect data. So if you're wanting just to see that it works in the very beginning, you can kind of brush over this discrete and not set up all the registers, and dang it, brush over all this discrete and then set up all the registers, and then that'll at least get you running faster with a minimal amount of code. That way, if you have problems, it's easier to. Dog is barking at my son, who is playing this game where it throws a pie in her face. So he had whipped cream all over his face. The dog did not recognize it. But anyway, so back to what I was saying. So this is the output section. This is the section that will run over and over and over. And so what this does is it basically checks the register for the distance and then sends that value out. And so here is the code, and I'll scroll through it again. I did put a very tiny delay in here, however, it really had no effect. Even when I commented out, it basically had the same result. So that's up to you there. So I'll scroll through these registers, which there's very few. There's only 1, 2, it looks like 3 registers that get set or used in this function. So that's the outputs function. And so now let's go, so this is the end of the code. And so if you have not used an S-function builder, so once you go through that and set all of those, you will have to build it. Click here, and it will say build. I'll go ahead and, you know what, I'll just go ahead and do it. So you build it, and then it will say successful, hopefully. And because I'm building mine, when it's already actually been built, I'm going to have a kind of a duplicate file, so I'll have to delete the old one and use the new one. And each time you change your code, you'll have to do the same process of building, delete the old one, and update the new one. It's running a little slow because I have a lot of windows open. A little slow, I mean a lot slower. So just while that's loading, looks like it just finished. You can see right now when I shine this at the camera that there's actually no light coming from it. There actually is a small laser that comes out of the square right here in the center. So if you're looking at it and you don't see the laser, it's a tiny laser, so you can look directly into the top. And you don't quote me on that, but when I look at it, it's not bright enough to hurt my eyes as far as the way I feel. So when I shine at the camera, you will see a little laser light, but as of right now, there's no light, so you know it's not working. So then we go, but it shouldn't be working, so that's fine. So now we go over here to the main Matlab page, and you can see right here I have the Vl6180X sensor driver wrapper.cpp and one that's a .c. Well, the CPP is the one we want, and the C is the newest one. And the same thing happens on another file. Which file? I haven't done this in a while, so I gotta kind of refresh my mind here. I have a bunch of other files in here that don't have anything to do with what we're talking about, so you can kind of ignore. Like you would not have this many files in here. What you'll need is the 2-wire C, the 2-wire H, and I think that's it. You might need these two right here, wire.h and wire.cpp, which are, all of these are pulled from the Arduino libraries. If you go into all the Arduino folders, into their libraries, just keep clicking and stepping down through the libraries until you actually find these actual files. Let's see here. So what I'm going to show you here though is when you click on this, it'll open up the actual code. And we're going to go into the wrapper, and in the wrapper, when you scroll down through it, there's two define statements. See it right here? There's one void statement, and there's the other one. Now this one, the CPP, is the one we want, but this one doesn't exist yet. This is my old one. I'm going to delete it. It became an untitled, so yeah, I'm going to get rid of it. Okay. Where are we going with this? Okay. So now this one is the new one that I just, when I built it, it creates this file. So when you build yours for the first time, this is the file you'll see. You'll name it whatever you want. You know, this is what I named it, but it'll say wrapper.c. So on this, we're going to rename it to the C++ file. We're going to open it also. Open it. Now it'll open here. And everything I'm doing here is common, so any videos you might find on YouTube will go through all this process too. I'm just giving you a supplemental on the same thing. So extern C. You have to do this for both voids. Scrolling fast, I'm just looking for it. There's the first one. Okay. Next. Okay. And then save. And now this is done. So what I want to do is I'm going to scroll through this code one more time. This is the same code that I was showing you on those tabs. One thing I want to note is you cannot change the code from here. This is not where you change it from. You have to change it from when you click, from when previously I was clicking on here, opening this, and I wrote it in the different tabs. I'll just do it again so I can show you. When I clicked on these tabs like here and here, this is where you change the code and then you rebuild it. If you try to change the code from being in the main Matlab menu or window and doing it here, that's not how you do it. So I wouldn't recommend just changing it like that. You can, but you know, it needs to be built. Okay, so I'll scroll through the code one more time. So for people who are, since I'm not going to upload the files as text files, so you'll have to copy it by hand. Scroll through here. You can see that this was the first, this was the output right there, and now it's going into the discrete update. So this is all the discrete update. So this is the code that is from those tabs earlier. Let's see if I can go a little faster. Also, there's one more thing I want to note, because you're probably going to copy my code verbatim, but then you'll probably make one key change that is just synonymous with writing your own code, which is you probably will rename your variable. The one I call distance, you'll probably call it something else, because it's just common practice. You'll probably call it DIS, or who knows what. So let me show you where that variable is. That way, copying my code, So you'll see where it says distance 0. This is referencing the word distance on the, let me go to it so I can show you. This is referencing this word distance right here, which is set up in, right here. So this word distance is this same word right here. Right here. And so whenever you describe your output word, whatever, this is the only thing that really will change in the code if you're not changing any of the registers or parameters or such. Okay, so enough talking, jabber. We're going to run it now. We're loading it now to a program. You can see down here in this window, it'll tell you kind of when it's loaded. It takes a while on my computer because it's slow. What I typically do is, a lot of times I won't even watch that window, I just wait for the lights to flash. So once you see the transmission, the receiving and sending lights flashing, then you know it's actually connected. Okay, so now you can see the lights are flashing, so it's now loaded and is starting to send and receive data. And I don't know if you can see this, but there's a tiny red laser, which will probably show up more like just a bright light in the camera if it's visible at all. There's a tiny red laser now flickering. It's very tiny, you gotta look pretty close. And like I said, the wattage of it is so low that literally it's like a dim light even when I stare at it. So now let's see exactly if it's working. So let me see if I can do it like this, see if you can see it. So now you can see there is noise in the signal. And setting the registers and stuff will help you to get, whatever distance you want, accuracy, etc. But you can see that it is measuring distance. And you can see it has a pretty decent sample rate, for motion. Probably anything higher than the motion I'm doing here will probably not come out. So let's just see here what we can do. So that's probably its limit right there. And in that shaking, it's probably not getting all those middle points. It's probably just getting more of the ends and that's why you're seeing it with waves, but it's probably actually not a clean wave. Okay, so, other than that, this is the Vl6180X time of flight range sensor, and which is actually a really good device. I liked it. It didn't work for my project, but it does work. And so, being that there was very little information out there with Simulink and the sensor, I thought, well, I might as well be the person to make one. So. Done. Oh, and also just FYI, if the sensor doesn't receive because I can see it on here, if it doesn't receive its return signal, it'll just kind of stick out wherever it was. So for instance, like let's find the distance here. So right here I'm at 80. If I just move my hand out of the way, it actually will stay at 80, and that's just because it never received the signal back. But if I put my hand back in there, it'll relocate what it was. So if it receives no object, essentially, then it's just going to stay at line at the last position it was. So that's why you see that line. Anyway, that's it.